With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says there are two particles A and B of mass 3 kg and 2 kg moving with speed 10 meter per second and 5 meter per second as shown in the figure. So we need to find the maximum momentum that the particle B can have after the collision with A. So we know maximum momentum transfer take place when the collision is elastic. So we can say during elastic collision we can say maximum momentum transfer take place. Maximum momentum is transferred. Alright, so from here we can say for elastic collision the value of coefficient of restitution is 1. Alright, so let's try to analyze the situation when they collide and get separate and start moving with different velocity. Let's suppose B is moving with velocity v2 and v1 starts moving with velocity v1. Alright, and we are considering the direction as same, so we are not considering it in the vector form. So here it is our A particle and here it is our B particle. So we have to calculate momentum of B, that is mass into v2. So first we have to calculate the value of v2. So from this coefficient of restitution, from this we can try to get the value of relation between v1 and v2. So we can write E is 1 and that is equals to coefficient of restitution is nothing but it is velocity of separation upon velocity of approach. So velocity of separation will be v2 minus of v1. As both are in the same direction, so we are not considering it in the vector form, so just we are subtracting it, and this can be written as u1 minus u2. Alright, that is velocity of approach. Therefore from here we can say u1 minus u2 will be equals to v2 minus of v1, or we can say u1 is given as 10 and this is our u1 value and this is our u2, that is initial velocities, so it can be written as 5 will be equals to, or we can say v1 plus 5 is v2. Alright, so this is, let's say, our equation number 1. So we are interested in finding the value of v2. So now what we can do over here is we can conserve the momentum in the horizontal direction, as there is no external force on the system acting. So we will consider both the particle as a system, and we can say on this system there is no external force, so we can conserve the momentum. So we can write by conservation of linear momentum, we can say momentum initial will be equals to momentum after, that is m1 u1 plus m2 u2 will be equals to m1 v1 plus of m2 v2. So finally what we can do over here is m1 m2 has been given as 3 and 2, so 3 into u1 is 10 plus of 2 into 5, and that is equals to, here it is m1 v1, that is m1 is 3 and we are interested in finding the value of v2. So we can write, instead of v1 we can write v2 minus of 5 from equation 1. We can write this relation also, and here it is 2 into v2. So from 1 we can give the reason over here. Using relation 1 we have written this, so this can be written as 30 plus 10, that is 40, and that is equals to 3v2 plus v2, that is 5v2 minus 15. So from here therefore we can say the value of v2 comes out to be 55 by 5, that is 11 meter per second. So this is what the value of v2 we have calculated. So from this we can calculate the value of momentum. So we can write maximum momentum, therefore maximum momentum of B after collision with A is equals to, we can say it has to be v2 into m2, and that is equals to 2 into 11, that is 22, kg meter per second. So this is what the value of maximum momentum B will attain. So this matches with option C, and I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.